There's one picky thing about these. If you're using your calculator to try and find the inverse cotangent of something, if it's a negative number, then to do that, you have to use the inverse tangent function on your calculator. You have to do the reciprocal of the value because cotangent and tangent are reciprocals of each other. But if you do the inverse tangent of a negative number, it's going to give you an answer that's in quadrant 4. Inverse cotangent is negative in quadrant 2. To get from a quadrant 4 angle to a quadrant 2 angle, what you have to do is just take the angle that it gives you from here and add either 180 degrees or pi, depending on whether you're in degrees or radians. And the other thing to remember, since you can't do the reciprocal of 0, the inverse cotangent of 0 is actually equal to pi over 2. Let's do a couple more examples. So here, if we're trying to find the value for arc cosine of 1, then that means that we want the angle whose cosine value is equal to 1. This would be 0. This is one of the ones that involves arc cotangent, so this is kind of a tough one. So what we want to do here is switch this to inverse tangent. So we're going to use inverse tangent. When we do that, we have to use the reciprocal of this value, so we do 1 over negative 0.3541. But what this is going to give us is an angle in the 4th quadrant. What we want is an angle in quadrant 2. So we're going to take this answer and add, since we're in degrees, we're going to add 180 degrees. So what we're going to get from this, if on your calculator this turns out to be approximately negative 70.5 degrees, we're going to add 180 degrees to that to get to the 2nd quadrant, which is going to give us 109.5 degrees. Back in the first unit, we did some problems where we drew a triangle on the xy axis, and we used that to figure out values for the trig functions. When we have something like this that combines two different functions, one a regular trig function and one an inverse function, we can use that same idea. If we just look at the inside of this, the inverse tangent of 3/2, if that's equal to theta, that means that the tangent of theta is equal to 3/2. So again, we're just taking that and turning it around. We can draw a picture of an angle that would have this as a tangent value. We're going to put this in the 1st quadrant since we've got a positive value for the tangent. Remember, tangent is y over x. So we want to draw this so that the y is 3 and the x is 2. So we're just taking this as a fraction and using that to make our side lengths. So we'd have 3 for the y and 2 for the x, and then we can figure out the 3rd side of our right triangle. So that would be the square root of 2 squared plus 3 squared, which would give us the square root of 13. So this is our r. So there's our theta angle. Now what we're trying to do, since we're using theta to stand for the inverse tangent of 3/2, we're trying to find the sine of theta. Well, we've got all 3 sides for this triangle, so we can find this. This would be y over r, which would be 3 over the square root of 13. Let's do another one like that. For this one, again, we're going to draw this in the xy plane. This time we've got a negative, so we have to figure out where to put it. We're going to take the inside of this and make this equal to theta. So if theta is equal to the inverse cosine of negative 5/13, that means that the cosine of theta is equal to negative 5/13. Now, if we were talking about just inverse cosine, we'd want to put this in quadrant 1 or quadrant 2. Since this is negative, it's going to go in quadrant 2. Now for our picture, cosine is x over r. So I want to make my x a negative 5, and then my r is going to be 13. That means I can find the 3rd side of my triangle, the y. This is going to end up being the square root of 13 squared minus negative 5 squared, which would give me 12. So the y in my triangle is 12. Now I'm trying to find the tangent for this angle, so I'm going to take the y over the x. That's going to give me negative 12 over 5. For this one, we're going to start out kind of the same way, but first we're going to look at this angle right here. Remember, anytime you have an inverse trig function with a value, that's actually equal to an angle. So I'm going to call this part angle theta. So I have theta equals arc sine of 2/5. That means that the sine of theta is equal to 2/5. I can set up my triangle, so I can make this the y and the r. 2 is the y, my 5 is the r, and then I can figure out the third side of my triangle. That's going to end up being the square root of 21 for the x. So this is my theta right here. Now what I have in here is sine of 2 theta. If I substitute the theta in from my arc sine expression. So here I'm going to have to use one of those double angle identities. That would be 2 sine theta cosine theta. And then I can find my sine of theta and cosine of theta from my triangle. So the sine of theta is y over r. That would be 2/5. My cosine of theta is x over r. That would be the square root of 21 over 5. So if I multiply all of these together, I'm going to get 4 times the square root of 21 on the top and 25 on the bottom. So that's my value for this. We can also do this kind of thing without actual values in our inverse trig functions. So if we just have a variable or a generic value in there, we can still write these as expressions. So what we want to do with this is we want to treat this as an angle again. So we're going to call this one theta. And when we have this u, since we don't have it written as a fraction, we're going to go ahead and write this as u over 1. And that means that the tangent of theta is u over 1. Now remember, tangent in your triangle, tangent is y over x. So we're going to make our y equal to u and our x equal to 1. That way we can find the third side of our triangle. The hypotenuse would be the square root of 1 squared plus u squared. So this would actually be just the square root of 1 plus u squared. Here's our theta. Now what we're trying to do is find the sine of theta. That's y over r. So that would be u over the square root of 1 plus u squared. And that's all that this was asking for, was for this value in terms of u. We can do the same thing with this one. So if we call this part our theta, we have theta equals inverse sine of u. And we're going to make this u over 1. That means that the sine of theta is u over 1. And we can fill in our triangle. This is y over r. So our u is going to be the y and our r is going to be the 1. That means to find this side, we would have to take the square root of 1 squared minus u squared. So that would be just the square root of 1 minus u squared. Now we've got the cosine of 2 theta. So we're going to have to use an identity for this. It doesn't matter too much which identity we use because we can get either sine or cosine. But notice for this one that the sine of theta is pretty simple. Let's use the identity for this that only involves sine. So that would be 1 minus 2 sine squared theta. We're going to write that with the square on the outside, and then in place of sine of theta, we're just going to substitute u. So we just end up with 1 minus 2u squared.